Now, today we will discuss about solidification of molten metal in the mold cavity. Now, solidification of molten metal in mold cavity is a very important topic which to be properly discussed. Now, this solidification of the metal, that can be a pure metal or can be alloy. This alloy again can be eutectic alloy and non-eutectic alloy. Now, furthermore, the solidification in the mold cavity, we will see that during solidification, two things take place. One is that nucleation. Initially, they nucleate, it form very thin, small particles. The another thing which happens that these particles they grow, becomes a big grains. Therefore, now that nucleation and grain growth depends upon the temperature gradient. Now, if the temperature gradient is high, then nucleation will be predominant, while low temperature gradient, low temperature gradient favors grain growth. Now, taking those things in view, now we want to discuss what is the behavior of during solidification of the pure metal in mold cavity. Now, one thing very important is that pure metal has a single melting point. Therefore, initially what happens when the molten metal is poured in the cavity, then a lot of heat, heat transfer takes place, that is a high temperature gradient is there, which causes nucleation, and fast nucleation takes place, causing equiax grains which forms the skin of the solid metal. Now, this formation of the equiax grains causes and releases latent heat of fusion. Now, when latent heat of fusion is being released, this stops further nucleation due to reduction in this thermal gradient. Therefore, later, what happens that at low temperature gradients occurs, and then grain growth increases. Grain growth continues, and they form what you call the grains to grow. Now, as the nucleated grains are very close, there is no way to grow other than towards the center of the cavity, forming columnar type of grains. Now, the solidification of pure metal can be observed that metal initially freezes at a constant temperature, which which gives the interface between the solid metal and the liquid metal, we having an in a common interface, which is having a common isothermal surface, which can be observed over here. Now we can see that here this is the interface, common interface having a isothermal surface, the solid and the liquid. Now here is the equiax grains, fine equiax grains, which we call solid skin. Now the final small grains, tiny grains, they when the grain growth is predominant, then this grows towards the core, towards the center, towards the center of the uh, cavity. Now, therefore, the figure can be seen over here. For a pure metal, the metal is growing towards the center of the cavity, from this side, and this side. This figure shows that of a pure metal, wholly columnar except for chill zone where we are having equiaxed region, because when the molten metal is poured in the cavity, they form a chilled zone with high temperature gradient causing equiaxed grains, and therefore this gives a typical uh, structure of solidification of of pure metals. However, this is that of the alloy. Partially, initially it is having an equiax, fine grains, stins, and then columnar, and then the temperature gradient is lower, and they form precipitate in between the molten metal, causing to develop equiax uh, grains, and therefore this is a typical solid solution alloy. However, in case of absence of thermal gradient, very low, and therefore what happens, that the nucleation takes place throughout the surface, structure, throughout the structure, causing equiax grains. This can also be achieved by using nucleation catalyst, okay, and having a heterogeneous nucleation throughout the cavity. Now, before going detail of that of the alloy, solidification of alloy in mold cavity, it is better to discuss the phase diagram, and easily, because we are using most of the time iron carbon alloy, and therefore let us discuss initially iron carbon phase diagram. If we look into this phase diagram, then we will see that there is the liquidus, this is the liquidus, this is the liquidus, and there is the now above this liquidus there is no solid. All the liquids have got uh, solidified. However, below this solidification temperature varies, but one thing very important to look into the liquidus, that the solidification temperature at this composition is different than the solidification temperature at this particular point, and therefore they are varying. They are having a range of solidification temperature, and moreover we see which is the solidification temperature goes down when we increase concentration. It is higher when the concentration is low, but it is lower when the concentration is high. Now another curve in this particular diagram is that we call solidus. This is the solidus. This one is the solidus. Now below this solidus there is no liquid. Below this is no liquid. Therefore, in between this we are having solid and liquid. And the molten matter between the liquidus and solidus is that liquid and solid. Now it is therefore mixture of solid and liquid. In between these two curves, solidus and liquidus, we are having liquid and solid mixture. Now composition of the solid is represented by if you draw a curved line, a parallel line joining the solidus and liquidus parallel to the x-axis, then this point gives the composition of the solid, while this position gives the composition of the liquid, and therefore the solidus gives the composition of the corresponding solidus point on the solidus gives the composition of the solid. Similarly, corresponding point on the liquidus gives the composition of the liquid. Now, one thing more very important, that you see we are increasing the composition, we are increasing the composition, okay, and increasing till we come to a point which we call eutectic composition. Now, at this eutectic composition, the solidus is and the liquidus, they meet, and they are having a single solidification temperature. This is the uniqueness of this particular point. Now, therefore, for a eutectic material in a mold, we are having a single, similar to that of the pure metal, having a single solidification temperature, and that therefore they solidify in the single fashion as that of the pure metal. The only difference is that, in addition to that, they give paralitic structure. Now, the size of this paralite depends upon the temperature gradient. However, formation of dendrites is to be discussed. Now, we know this particular iron-carbon phase diagram. Now, therefore, at this particular point, the solidification takes place of a particular composition. The composition is over here. Now, at that particular composition, when it comes to the touches the liquidus, solidification starts, and the composition of the solid is that of the composition corresponding point on the solidus, and composition of the liquid is that of the composition of liquid is that of the corresponding point on the liquidus. Okay. Now, therefore, the composition of the solid is less, and composition of the liquid, the concentration of solid is less, and concentration of the liquid is high. Now, initially it was at this point, but after solidification, concentration increases, and moreover the solidification temperature reduces. Now, therefore, what happens that in liquid, the liquid adjacent to the solid, they are having higher concentration, and the solid having lower concentration, and therefore the liquid ahead, they are increased, the composition, the concentration getting increased, and solidification temperature gets reduced, which causes the solidification in the liquid itself. As concentration has increased and solidification temperature has decreased, therefore in liquid itself, you see, formation of nucleation will take place, and formation of solid will take place, causing to precipitate and forming a grain. Now they grow and they stick, and therefore similarly at this corner, that corner, they go and they give dendritic structure. Now there are different types of morphologies, can be this type or that type, depending upon the material, being of course controlled by the ingredients of the alloy, and the temperature gradient will describe. Now, therefore, for a particular, if you look into the formation of the dendrites in the mold. Now, if we look into that, then we will see that after 8 minutes, we are having this shape. Now, after 11 minutes, the further growth has taken place towards the cavity, at the center of the cavity. Similarly, after 40 minutes, you can see there are liquid over here. There are liquid at the faces. Even then, the formation of particles are taking place in the core of the cavity, and after 60 minutes again they start, as they have reached the center, therefore they start growing, and finally they give the complete solidification takes place after 102 minutes. Now this is all about the solidification, and this is how the formation of columnar type of grains are being formed in pure metals or eutectic metals. And while in case of non-eutectic alloy, we can see how we are having this dendritic type of structures. Thanks for hearing the and concentrate having the concentration on it.